Last video of the day. Yay. Math 2, Miller, Unit 6, Chordal Geometry. All right. Today, using a graph to find and prove the intersection of a line and a circle. And I think we're doing parabolas too, but so far it's just circles. Where do they run into each other? That's the question. Well, here's a graph. We've got an equation of a circle. This is going to be tricky for me to graph without a compass or anything else, so I'm going to have to wing it a little bit here. So let's see, where's my center? 3, 2. There's my center. And if I think about this, my radius is 5. So if I just go 1, 2, 3, 4, 5, left, 1, 2, 3, 4, 5, right, 1, 2, 3, 4, 5, you get the idea? Up and down, 1, 2, 3, 4, 5. That gives me a pretty good approximation, and I can kind of draw my circle from that. It's not going to be perfect, but it's going to be a reasonable circle. All right, we're going to go with reasonable. And then we're asked about a point. What about the line y equals 6? Okay, we're going to actually draw that line. I'm going to throw it right on here. Y equals 6 is about right here. So the question is, what are the points? Where does it intersect? It looks like to me it's somewhere around here and here. So it looks like we can kind of see that. How can we verify it, though? That's the question. How do we actually verify it? Easy. Plug the points that we think it is into the equation and see if the radius is still 5. Because really what we're looking for is equal to 25 here. I mean, that's the whole point, is that it's equal to 25. So let's just do that. So if we think the point -1, 6 is on the line, well, that's going to be x minus 3. So x would be -1. -1 minus 3. Well, that's -4. When we square it, we get 16. Okay, so far, the other one equals 3, we're good to go. That would be 6 minus 2 over here. 6 minus 2. So that's going to be 4 as well. So we're going to square that. So that means we're going to get 16 plus 16. That is not 25. That is 32, not equal to. So that point is not on there. Now, at home, use a compass, and you'll get a little more accurate of a read on this. We're trying to actually find those points where it hits. So it's really tough to do this without a compass. So that one it appears to not work. Now we can check the other one as well. We can just go check through. Let's do that. It appears that the point 5, 6 is on the curve. Same thing. If we can check the left side of the equation, 5 minus 3 is 2. And if we square that, because we're supposed to square it, that's 4. Okay, and then come in the other direction. We're just trying to see if this equals 25. That's what we're doing. We're just trying to verify that some of those squares are equal to 25. We're just verifying the Pythagorean theorem is what we're doing here. So let's do the y's. I'm saying that that's 5, 6. So the y's are 6 minus 2. And that's 4 squared is 16. That means that 20 is not equal to 25. So that point is not. So we would have to really be a little more accurate with this with our graphing. So just drawing a circle like that is not going to work. But you see how we verify it? Draw a good circle with a compass. Check it out. You can also put it into Desmos as well. Desmos would work just fine for checking it out. Put the equation of the circle into Desmos and just trace around it. That's another good way real quick to do that. All right, so that's the idea. Graphing the circle, making sure, checking to see if it is actually on the circle or not by verifying that distance from the center, which is right here at 3, 2, to that point. All right, and there we have it. Here we go. Let's try another one. Creating lines. So we've got a circle here. It says write an equation for the circle. Well, it's got a radius of 10, so it's going to be 100 equals, here's my y's. It's just going to be x squared and y squared, actually. The center is 0, 0. So it's just going to be x squared plus y squared equals 100. Pretty much standard Pythagorean theorem there. Graph and write equations for each line described. Oh boy, any line parallel to the x-axis that intersects the circle at 2 points. So parallel to the x-axis. So any line is fair game here. So I'm going to go with, I'm going to blow this up on my end. Any line parallel to the x-axis. Okay, this circle's drawn accurately, so this makes our life a little bit easier. There's a line parallel to the x-axis, and now I can kind of see where it intersects. Looks like right here. Right here. So at the points, that's -6, 2, 4, 6, 7, 8. And over here we're at 6, 8. And then we can verify it. Basically go through and say, okay, well, let's check it out. I'm just reading the directions real quick, and I'm looking at, hey, wait a minute, it just says draw it, and then perpendicular. It says it does intersect the circle. Oh, that doesn't intersect the circle. That's easy. A perpendicular line, any line perpendicular to the x-axis that doesn't intersect the circle. I'm just going to keep drawing lines here for a moment. So let's take care of the lines first. I'm going to draw one out here. Go way out here. How about right there? Okay, there's your perpendicular line that does not intersect. And then it says, draw the line perpendicular to y equals 1/3 x plus 5 and intersects the circle at 6, 8. Wow, that's a pretty tall order. So let's take the tall order and let's graph it. Here we go. First of all, we need to actually figure out what's going on here. Perpendicular. That means that right there, there's a slope of -1/3. It's going to have to be y equals 3x, but then we want to do it. We want to do it in point slope form because it says it goes through this 0.68. So y minus 8 equals that slope again. Once again, it's the flip and switch, flip the switch, minus 1/3. So that's going to be positive 3, and the slope of x minus 6. And it says, okay, we got to graph that. So how do we graph it? Well, let's see. Where's the point? I got to get to the point first, and then graph the point. 6, 8. 6, 8. Okay, well, it's right there. We've already got that point, actually. That point's already on there. We just need to make a line that has a perpendicular slope to that. There's a slope of 3, so this is going to be a little tricky. So y minus 8. Okay, then that's it. So I've got to be really careful about how I draw this thing. Let's see. Starts there. Slope of 3. So I'm going to go down. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3. Okay, so let's see if I follow that along. Let me go back down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then 1, 2, 3, 4, 5, 6. Right there. Okay, so that looks like that's what I'm dealing with. So it looks like there's another point of intersection right there. So graphing that line is a little tricky. Find the second point where the line intersects. Explains how we showed it. Well, we graphed it, and we think that it exists right down here, right down there. So let's just verify it. Let's just check the circle again. X squared plus y squared equals 100. So that point is -1 squared, which that will be just 1. And then y was 10. -10, and we're going to square that. That's 100. So 101 equals 100. You might say to yourself, no, that point's not like it's. That's just my graphing most likely. I'm graphing fat lines on a little skinny graph here. So that one, if on your page, you're probably going to be drawing a lot bigger. It probably most likely is close to that. If not, it's very close to that. So you're probably going to have a little more going on there. But in this case, I would say that, as my drawing says, No, I would say no, it's not on there, according to the way I calculated here. But they're asking you to try to find one exactly if you can. So your graph will be a little more accurate with your big picture. I'm drawing on an iPad and going from there. So that's the deal. Just, like I said, getting the drawing, getting the graph, verifying that it's on there by using substitute and evaluate. So that's what we're doing. We're still subbing and evaluating just to check that distance being equal. So we've been doing that for quite a while now. All right. So there's our summary. Now in the summary, we can pick this apart a little better here. Let's pick the summary apart a little better and go over here and say, you know what, right there, 5, -18. That we can actually see. There's the center of the circle. It's at 10. Looks like what they say the center was here, 10 at -6, right there. And we can actually say this point down here, we can actually totally verify that at that point by just putting it into the equation. So here's our equation over here. You're just subbing it in and you're checking it out. And in this case, the point is on the line if the radius is 13. So you're checking to see if it's 13, which actually be 169, 13 squared. All right? So that is the idea. That's our summary right there. That's all we're doing. Let's try one out here. Here's our equation. Let's see if we can do this without a compass. Like I said, a compass really helps here. Here's our point, center of the circle, 2, 3. So that's our center, and that 3 is negative because it shows up as positive. So 2, -3. 1, 2, 3. And then it's got a radius of 6 because of the r squared. So I'm just going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. I'm going to try and draw an accurate circle. This is the tricky part.